People are still there. All right, I'm back. I'm glad some people stayed. This is great. And now, if anyone has a question there, I'm just kind of reading the thread, and let me know if I didn't answer a question yet. But I see 52 and 53. All righty. Now, let's have a look. And I am recording now, so good. Okay. Where's my marker? There's my marker. Okay, so what do we got? 52 and 53. '52. Which acid ionization constant would indicate the strongest acid? It's exactly the same as the one we just did. Okay? K is bigger than 1 when K is equal to 1 and when K is much smaller than 1. This will be for products, but this just means big, small, and when this number is around 1, you'll have 50-50. And this one here will be the reactants. So that's a good one to know. So 52 and 53, you're just looking for the biggest, smallest number, or the number around 1. Looking for the biggest number, the smallest number, whatever the question is asking you. Okay, so for 52, which one indicates the strongest acid? So think about that. Here I have an acid plus water. Now, a weak acid will have arrows going both ways. Okay? Okay, because it's 50, we don't know how, only some of it breaks. But a strong acid, HA plus H2O, there's only one arrow. Okay, so this is a strong acid. So when I put a strong acid in the water, where is it going to go? Products, which means that I'm looking for the biggest number. Okay, so that's what we're talking about there. 53 is this it's basically the same. Solubility. This is something there that we haven't talked about yet. Okay. For all Ks, Ka, Kb, Ksp, this all follows suit. The biggest will be over here. Small Ks will be over here. Ks around 1 will be 50-50, the same. So let's have a look at solubility. Okay. The bigger the K, the bigger the solubility, the bigger the products. The smaller the K, this thing is not going to dissolve as well. So when you're talking, let's find a KSP one here. So to answer question 53, which solubility product constant indicates the most soluble salt? Okay, so if I have, I don't know, sodium chloride plus water, okay, so it's going to break into this and this, plus your water, okay. Now, if it has a high K value, it's going to be on this side, okay? If it has a low K value, it's not going to dissolve at all, it'll be over here. So, if you look at this one right here, 53, which soluble product constant indicates the most soluble? So there you're looking for your biggest K value. That's all you're looking for there. The smallest K value, that will mean that it's not dissolving at all. All right. Just looking for a KSP. Oh, okay. Now, yeah, 58 and 59, those are KSP, but there's a bit of a step involved. Okay? And we can try these out just because I want to show you a KSP. Now, this is all about solubility. I put an ionic salt or something into water, and how well does it dissolve? So, what is the solubility? Actually, I'm going to find a different KSP one. I want to go back to the lecture. And I'm going to go away from the board for a second. And I want to screen share. Because what I really want you guys to look at for your quiz, Whew, man, it's getting hot in here. Where is it? I think that was what, week 4. Yeah. These are what I want you guys to look at right here. And all of these examples, I really, really like them. Okay? All the KE, there's your shifting. Okay? And shifting left and shifting right. Oh, there's some good words there. A buffer, a catalyst. Know that a catalyst does not change a reaction at all. Doesn't change the output. It comes out of the reaction unscathed, untouched. Okay? But if you have a look here at, these are great. I love these. And they walk you right through it. There's your x squared. This is all from week 4. Have a look at this one here. Actually, I think that this is for your quiz coming up. All right? But let's have a look at this one right here. Here I have calculate the solubility of silver iodide. Okay? Now, what do we got? Calculate the solubility. So you have your formula, AgI, and this is how I want you guys to do this. Now, can I go into... Oh, man. I can't move it. Thank you for getting out of the way. Slideshow. Current slide. So you have this here. Calculate the solubility of silver iodide at 25 degrees. Okay? And this is how I want you guys to do this. You guys have this here. With solubility, there's no chemical reaction or anything like this. You just dissolve. This is in solution. It's a solid. Aqueous. It will break. All right? But look at this K value of here. 10 to the negative 17. What is that telling you? This stuff is not very soluble at all. Okay? So, how we do this is, now, every time one of these guys breaks, all right, you're going to make one of these. And you're going to make one of these. All right? That's what I want you guys to know here. And you guys have plus X and plus X. So here's your KSP equation. Remember, it's products over reactants. So you have your AgI produces Ag plus and I negative. All right? And products over reactants. These are my products, if you guys can kind of see. And these are my reactants, but my reactant is a solid. So for KSP, you never have a bottom of the equation, which we see right here. Okay? That silver iodide, it's a solid. It's not included in the equation. It's not on the bottom. So this is your KSP formula here. Plug and play. And you'll notice here that for every time one of these guys breaks up, I get 1 and 1. So have a look here. Let the amount equal X for these guys here. So here you have KSP is equal to X squared. Well, I've given you the KSP, okay? And that's how you do this one here. Sorry, river preview. So as far as KSP goes, this is what you're looking for. And notice there that the molarities are 1 to 1. 1 to 1. Have a look at this one. This one here, the molarities are 2 to 1. So calculate the solubility of mercury bromide, okay, if the KSP is 1.3 times 10 to the negative 19. Sorry, I guess you guys are, all you guys see is my neck. All right, so have a look at this here and notice that you have a coefficient here, okay? And when this guy breaks, one mercury is going to break, but 2 bromines are going to break. So one of these will break, will produce X and 2X. Crazy important because you need that 2X in here. And remember that there's a coefficient, so there's a square on the outside of the bracket. Okay, let everything equal to X. So KSP is equal to X times 2X squared. And 2X squared is 4X squared times X is 4X cubed. Okay. Divide by 4, get rid of the 4. Okay. X is equal to 3.2 times 10 to the negative 7. Okay. And be careful. There's a square root, but in this case here, you will need to do the cube root, which is function on your calculator. Okay. So that's how that one works. I don't know if you guys have any more questions or talk to me.
Why on that one do you have to do the cube root?
Yeah, only for all of your am I still sharing? Yes, I am. Okay, good. For all of these equilibrium questions there, you should do, and I'm saying this to myself in my head, but when one of these guys breaks, how many of these guys do I break? How many of these guys come? And you'll see here that if you look at the previous question here, it was 1 to 1. So when one of these guys breaks, I make 1 and 1. So they're both the same. So they'll end up being X squared, X and X times. But just the physical mechanics of all this, what happens here is if you get 2, okay, you do the same thing. You got X, 1X, but here you got 2X. That's just the way it goes. And then when you make your KSP formula here, don't forget about that squared. So this, if there's a 2 out front here and you're dealing with KSP, it's going to affect you twice. You've got to put in a 2X, and then you're going to have to square it. So then you let X represent everything, and you end up getting 4X cubed because 2X all squared, 2 times 2 is 4. X times X is X squared. So this whole thing here turns into 4X squared. All right? And multiply by another X gives you 4X cubed. And you'll see that number a lot when you're dealing. Yeah, go ahead.
So, can you, like, does it make sense to say, like, if they're, because there's the 1X and the 2X for the bromine, you just add those and that's what your X is? Is that why you have the X cubed?
Oh yeah, that's yeah, the like 2X plus 2X is equal to 4X. And
so if there was like 4 bromines instead of the 2, would it be
you're
X
not,
to the power 5?
Yeah, you're not really adding here, you're multiplying. You've got here, I'll see if I can do this somewhere where I don't have right here. Okay. So you have basically this whole thing here is equal to X, and there's a 2X and a 2X. And you see you're multiplying all of these guys together, okay? And We're not adding. This is multiplying. And you can only multiply what you can multiply. So 2 times 2 times 1 is 4. And now I have x times x times x, which is x cubed. Okay? Talk to me there. That's the math involved, and that's what we're looking at right there. So you're multiplying.
Sorry. If you do the x times x times x, 3 x's, why are you only doing the 2 2's?
I'm multiplying 2 times 2 times 1.
Oh, right, okay.
Right?
Right.
So it's 2 times 2 times 1 is 4. And then x times x times x is x cubed.
Okay, I see.
Are we okay?
Yeah, that makes sense.
Good. No. Hey, man, great question. Great question. What else we got? Ooh, what has happened there? Talk to me. Guaranteed you'll see that one there on the quiz and on the test. Okay? And you can see that they're... Once you do these questions, you know what I mean? You set them up the same way every single time. So that once you've got your knowns, your equation, then you could start branching out and looking for this formula, but you kind of set it up, pull everything out so that you can strategize and create a plan of action. But talk to me, what do we got? I don't even know what time it is. Oh, we're getting there. Any more questions? What do you guys got? Sorry, I have. I don't have the blurb on. Anyone going to provide? No, I'm not going to provide the answers to the review. If you guys want answers, email me, and if one of the questions there is bothering you, sure, I can do that. I can't do 150 questions, but that's one of the problems there that I miss is being able to do the whiteboard and be there with you guys and to look over your shoulder and watch you do a question so I know you're doing it right. But that's where, please, if you don't get a question twice, email me. Okay? Don't waste your own time because you guys have enough and couldn't even imagine how many exams and assignments and labs and everything y'all got due in the next 10 days. So just take care of your own, and if something doesn't seem to be working, let me know. Okay? Any more questions? 4, 6, 15. Great, Abigail. Let's have a look here. 4, 6, and 15. Aha! Excellent. I like number 4. Let's have a look here. Now, why is the black marker easier to wipe off than the... And what did I just do with my black marker? Oh, there it is. Okay, so number 4. You guys can see all right there. And... camera settings mirror my video. No. Camera settings. Oh man, I hope this works out. No. Rats. I don't know how to get... No, I didn't want that. Now I've just lost my entire self. There I go. Someone. I don't know why. Mirror my video camera settings. I don't know. Raise hand. Mute. I don't know. That, I don't even know if this is going to work or not. We'll see. But anyway, number 4. Calculate the number of moles of excess reactant that will be left over. 2Ki plus Br2 produces 2KBr plus I2. Okay? So, what did I... Oh, yeah. This one here, this is a good one. So, I got 50 grams of Ki and 50 grams of Br2. So 50 grams and 50 grams. 2, 1, 2, 1. So now this is a limiting reagent. Okay? Oh gosh, man, why is my video... This makes me... Camera settings. Why did my camera flip? There we go. At least that's better anyway. I don't want to do that. I don't know. Whatever. So, let's have a look here. Abigail, you look at this question here. This is a limiting reagent question. All right? And these grams I've given you are no good. So the first thing you got to do is you got to change this there to moles. And this one here to moles. And that's using your triangle formula. Okay? If you're having issues there with that, then let me know. Okay? Because being able to change grams to moles will need you. So then you have your moles of whatever this one here would be. And you have your moles of whatever this one would be. Then you do a scenario 1 and a scenario 2. All right? So if somebody wants to figure out, if somebody can figure out the moles of potassium iodide, and somebody else could figure out the moles of bromine, that could save us some time. All right? But that's how we do this here. I give you grams, you've got to change it to moles. All right? And I'm going to see if I can try and switch audio, mute, camera settings. No, it doesn't like it. I don't know. Grid, stage, focus, full screen. No, didn't like that either. Layout. Exit full screen. So why aren't I the stage? That's so weird, man. Why? I don't know. I don't know. For some reason, Shaylin, you're the focus. I don't know what's going on here. I don't know why it's gone to this. Anyway, let's go here. So changing this there to moles and this there to moles, and then you do your two boxes as normal. What do we got here? I don't know. Anyone find out the number of moles of these guys? Okay. So you would find out the number of moles in here, and then you would do one box. You'd find out the number of moles of this one. You'd do another box, and you'd cancel which one of these guys here. I could figure out, but it'll take me 5 minutes there to figure these guys out. If you guys want, try this there at home and let me know how your answer goes. Okay? And one of these scenarios will be false. One of them will be real. These will be your numbers. And the limiting reagent will go to 0. Anything you have after, that is your excess. Yeah. What do we got? Ask another question if I didn't explain that. But, how we doing? Sorry, guys. I need you guys to talk to me here. You don't understand? Okay. Well, all right. Then how do we figure out the number of moles of this? Your number of moles, your formula, number of moles is equal to grams divided by molar mass. That's from your formula. So we're dealing with this one because I can't deal with grams. I'll have 50 grams divided by, I don't know what the molar mass of potassium iodide is off the top of my head, but potassium is 40, iodine is 127. 40 and 127 is 167. So 50 divided by 167. So this one right here is 0.30 moles. Okay. This one here, I got to figure this one out. So I got to go number of moles is equal to grams divided by molar mass, which will be 50.0 grams. Molar mass of bromine. Oh, that's going to be massive.
It's 0.3144.
Okay, all right. Now, hold on here. 79 is 140 is 138. Sorry, what did you get?
0.3144.
0.3144. Okay, good enough. Perfect. So I got 0.314 moles. Okay. And 50 divided by... I got a different number. Maybe I did something wrong here. Iodine, now bromine is... Oh, it's 80. So it's 160. Sorry, I did something wrong here. And 50 divided by 160. 0.3125, that's what I got. What did you, is everything all right there? Did you get the same number? 50 divided by, my number's changed here. But, so.
I got 59.
Sorry?
Instead of 160, I got 159.
Perfect. It's all good. I'm just going quick.
Instead of 160, I got 1.
Sounds good. Sounds good. So somewhere in here, numbers don't have to be exact because your periodic table will be a little different from mine. Okay? And I mean on like a thousandth of a gram. Not a big difference, but it will change your number a little bit. It's okay. Carry it through because there's only going to be one number that's right. A, B, C, or D. There's not going to be anything close. All right? So now I've got my moles. Now we can actually begin the question. So these are my molar ratio. Okay, 2, 1, 2, 1. These are the moles that I've given you. All right. Which one is going to go to 0? And by the way, this is about as tough as it gets. All right, as far as calculations go. And let's just scenario 2. And so here I have 0.3 moles. That's real. So I'm going to try and find out if this one will go to 0. And then in scenario 2, I'm going to try and figure out if this one goes to 0. All right. So if this one goes to 0, how much of this must I have used? Well, the ratio is 2 to 1. You can do a box, but you can just see that if I use 2 moles of this, I need 1 mole of that. Okay? Well, if all 0.3 moles of this goes away, that means I needed... This is hypothetical. All right? So if all of this stuff goes away, I needed 0.15 moles of this. Do I have 0.15 moles? I do, because these are my real numbers here, and I do have that. So that is a possibility. Now, if all of this goes to 0, 0.313, how much of this would I have needed? Well, it's ratio 1 to 2. I can do a box, but I can just see that if 1 mole of this, I need 2 moles of this. Well, 0.33, I'll need double. So that'll be, what, 0.626 moles of this. So if this is going to go to 0, I need 0.626 moles of this. Do I have it? No, I do not. So therefore, that one there is a false statement. This is what is going to happen. Okay? I am going to run out of this first. So this is my limiting reagent. All right? And when this goes to 0, I'm also going to take this amount of this guy with me. How much of this guy is left over? And I had 0.313, and I'm only using 0.150. So hopefully there you guys can see that there. I'm 150, 160, 0.163 moles of Br2 are in excess. That's the answer. Now whether it's looking for right there, 0.163, and the only answer that's available is 0.162. So that's your answer there. How are we doing? Talk to me, talk to me, talk to me. It's heavy, but this is why you'll see a couple questions like this on the quiz. And you see here, this question here is nasty because I gave you grams at the start. A question is nasty when I give you grams at the start and you've got to change to moles. Or a question can be nasty when I'm asking for grams at the end. You see this here? 0.163 moles of bromine. I could ask you for an extra step here and tell me how many grams of bromine. So what would that mean? You've got to take 0.163 moles of bromine and then change that into grams, which you can do easily enough. But it's an extra step, right? And so that's what's going on here. I break this down into scenario 1 and scenario 2 because you can never go wrong with it as far as I can see. But you don't have to do it like this. You can actually go quicker. You know, this isn't I just do this as a visual representation. But once you see there, okay, 1 to 2, 0.31, that'll be 0.626. Okay, all right, so this is going to be my limiting, this one. You can actually kind of do it once you kind of see it. But if you go by this step, limits your ability there to make a mistake. All right. Talk to me. What else we got? I have no idea where my communication screen went. Just now went. When you're talking excess, you see limiting reagent. So in this case here, we proved that all of this 0.3 moles is going to be gone. All right? And because of the molar ratio, all right, 2 to 1, half as many moles are going to be gone here. So this is going to go to 0, but it's also going to take this much with it because the molar ratio says so. How much of this is left over? That's what I mean when I'm talking about excess. Okay? So you got to go through the whole process, and then at the very end, how much of this stuff is left over, subtract how much you had there for when you got used, and you should get a final amount there. So hopefully that's about as clear as mud. Talk to me. You guys have a lot of work to do. You guys are doing great. You guys are here at the bitter end fighting, and I appreciate it. I really do. Talk to me there. I think we still have some time. I can't tell. My phone is off. Finally, my phone is off. What do we got here? Another question. Anybody? Talk to me. $32. Let's have a look. Aha! Excellent. The pH of a solution can be calculated from the expression. Which one? pH is equal to the negative log of the hydrogen concentration. Be careful, you might see it written like this. Same thing. Okay? So that's your formula there. So what's my answer there for 32? No, the next 32, I think. Sorry, guys, tell me I'm confused.
There seems to be two 32. So the one is the pH of a solution can be calculated.
Aha!
And then the next one is the net ionic equation.
Oh, I love it, man. I love it. I love it. Yeah, I see it. Yeah. It's all good.
Great.
Let's go. Cool. Now, the net ionic. Aha. You will see this one as well. Now, you remember there are atoms in a chemical reaction that are busting it up and they're a part of it. But then there are atoms in a chemical reaction that are just sitting around on the bench. We call these guys spectator ions. They're not really involved, but they're there. And if you, so 32 number 2, 32 the second 32. What is the net ionic equation when hydrobromic acid reacts with potassium hydroxide? This one here is nasty, not the procedure is all right. But where I'm getting you on is I'm making sure that you're going to write hydrobromic acid correctly and potassium hydroxide correctly, and you're going to do the chemical reaction correctly. That's what this is. So let's have a look here. Hydrobromic, okay, plus potassium hydroxide. Is blue okay? Can you guys see that? Produces. Did that crack already?
Not really well.
No? Okay, cool.
Sorry.
No, sorry. Hey, man. If it ain't working, it ain't working. Okay. What do we got? HBr plus KOH. So this is an acid plus a base. Always produces. So I got H2O. Now what's my salt? Like you see there, H2O. So potassium bromide. Okay. So that's my chemical equation. I think it's balanced. 1 to 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 1. It's good. Now, what is it asking me? What's going on here? What is the net ionic equation? Now, this is where you got to be careful. Aqueous means both these guys are in a solution. Solution A, solution B mixed together. Okay, aqueous means in the water. Water can't get in the water. Water is water. So that's a liquid. And potassium bromide, this is aqueous. All right. So now what we do is we start breaking things up. H plus Br minus plus potassium ion plus OH minus produces water. No breaky because it's not an ionic, it's not, you're not breaking this up into the same style because it's a liquid. And then you got potassium and bromine broken all up. Okay? Now what you do is you start slicing and dicing. What you have on one side, if you have the same thing on the other, cut it. So, hydrogen plus, no, hydrogen stays. Br minus, gone. Potassium, gone. Hydroxide, no water. See these guys here? These are your spectator ions. Okay? And then there you go. This is your net ionic equation. And the net ionic equation just gets rid of all the fluff and the spectator ions, and this is what you're looking for there. Good question. Love it. You'll see it. How we doing? Ladies and gentlemen, and that is that looks like it's it. You guys got another question? Then what I want you guys to do, have a look at that one too, eh? All right. There on the last page, might be a question on there like that one as well. But I've broken the video up into 3 parts, so there'll be part 1, part 2. I'm going to upload those right now to YouTube. And will we have time during our lab to ask questions there next week? Sure. Because next week I'm going to give you a lab. But yeah, sure. That'll be a tutorial. And yeah, we'll use that as well. Plus, shoot me an email anytime, and I'm pretty good. I check my emails all day long. And but let me know what's going on and keep me posted. Okay? Thanks, guys. I want you guys to have a great day and keep me in the loop. If anything's bothering you, let me know. We good? No, it's all good. I appreciate you picking my brain. Keep picking it. We'll get you there. We'll get you in. We'll get you out of here and get you into where you guys need to be. But thank you. If you guys don't have any questions, I'm off to go and harass my children. Did I see your email? I don't know when you sent it there, Abigail, but I'll check and I'll respond. If it's an emergency, let me know. But if not, I'll get back to you. Give me a little bit and I'll get back to you. Okay? Thanks, guys. Have a great day. Be well. Bye, guys.